Hello dear curious students. Today we will learn about Thomson's model of atom and Rutherford's scattering experiment. After the discoveries of subatomic particles, that is electron and proton, scientists were curious to know how these charged particles are distributed in an atom. Thomson presented a first model of the atom. He proposed that positive charge is separate over a sphere of the atom, and the electrons are embedded to make the atom as a whole neutral. This model resembled like a watermelon, in which red flesh represents the positive charge of the atom and black seeds represent the electrons. Thomson compared an atom to Christmas pudding, in which electrons are like raisins in the pudding and the pudding itself is as positively charged particles. But this law had limitations, as it could not explain the stability of the atom and the results of the Rutherford scattering experiment. Rutherford's scattering experiment contradicted the Thomson model, which proposed that positive charge is separate throughout the sphere of atom. Let us now understand the setup of his experiment. Rutherford placed a thin sheet of gold foil in a vacuum chamber. The reason for using gold foil was that it is very malleable so that most of the alpha particles would be able to pass. He fired a beam of alpha particles at the gold foil. Alpha particles are doubly charged helium atoms emitted by radioactive atoms such as polonium. He used a fluorescent screen to detect the alpha particles. Rutherford observed most of the alpha particles passed through the gold foil undeflected. Few alpha particles were deflected by small angles, and very few alpha particles, 1 in 20,000, deflected by 180 degrees. From this experiment, Rutherford concluded most of the space inside the atom is empty, as most of the alpha particles passed through the gold foil without any deflection. The deflection and backscattering of some alpha particles indicated the presence of a small, dense, and positively charged nucleus. Rutherford proposed that electrons, which are positively charged, orbited the positively charged nucleus in a manner similar to planets orbiting the Sun.